All right, the last concept in the unit of stoichiometry is percent yield. In percent yield, pretty much it's a mathematical formula which is investigating exactly how much or how close did we get to a 100% reaction. Okay, so if something is a 80% yield, that means we got 80% of the maximum amount of substance produced. So that tells us how good we were in getting product formation from the reactants. Now again, theoretically, it's impossible for every single particle to react because the chance of the collision of all the molecules occurring in a system is improbable. All right? So even most reactions to expect 100% yield is highly unlikely. Okay? Now, there's two yields. You got three yields here. The first yield is called the theoretical yield. The theoretical yield, or the literature yield, this is the yield where we have perfect conditions. So we assume 100% complete reaction. And how do we figure that out? The key is stoichiometry. When we do stoichiometry, we are assuming that the limiting reactant, that all of it forms product. Okay, so we can use stoichiometry to assume 100% complete reaction, and this is the absolute max of the product that can form under ideal conditions. That's what stoichiometry allows us to do, to calculate the absolute max. The actual yield, or sometimes also called the lab yield, or experimental yield, all these words mean the same thing. This is the amount that we get when we actually perform the experiment. Okay, so when we do the experiment, we've got to figure out a way to measure the mass of the substance produced, and that is called the actual yield. Now, if you're doing a lab, that's what you'd measure in the lab. If it's a problem on the test or the quiz, this will be a given value to you, okay, in the problem. That is because you can't do the laboratory if it's a problem that you have to do off of, unless you had access to a laboratory to go ahead and do it. Okay? So, again, we're going to write the balanced equation. We are going to calculate the theoretical yield using stoichiometry. And then we're going to calculate the percent yield by somewhere in the problem we are going to be given the lab yield, or the actual yield of the experiment. So you've got to be able to look at the numbers and identify what number goes with what. All right, so here it says when 45.8 grams of potassium carbonate reacts with HCl in the lab, 43.3 grams of KCl are produced. Water and carbon dioxide are other products. Calculate the theoretical yield and the percent yield of KCl. All right. We have already been told an amount of KCl that was produced. The 43.3 grams of KCl. Okay, is it the theoretical yield? Is this the theoretical yield, or is this the actual yield? Hopefully you're saying that this is the actual yield, or lab yield. This is how much they got when they did the experiment. All right? So what we need to do yet is to calculate the theoretical yield, and that is by using stoichiometry. So what we've got to do is take 45.8 grams of potassium carbonate, which is my reactant, and I've got to figure out how many grams of KCl is theoretically possible. What is the absolute max amount of KCl that I could have produced from that potassium carbonate? To do that, we're going to do stoichiometry. All right, so we have potassium carbonate react with HCl to produce KCl, water, and carbon dioxide. All right, I'm going to pause the lecture now. When you restart the lecture, I'm going to have it balanced. So go ahead and balance this reaction and see if you get it correct. All right, you should have a 2 in front of the HCl and a 2 in front of the KCl, and the rest of them are 1s. All right, so now we're going to do mass-to-mass stoichiometry. 45.8 grams of potassium carbonate. A mass-to-mass problem, as we've done so many times before in this unit, is a 3-stepper. As I said, if you can do mass-to-mass problems, you should do extremely well in the test and the quiz because so many of the problems are mass-to-mass. All right, the first step is to divide the mass of the compound by its molar mass. So we need to figure out the molar mass of potassium carbonate. 39.1 times 2 to get the mass of potassium, plus a carbon, plus 3 oxygens. That'll convert the grams of potassium carbonate to moles of potassium carbonate. Again, whatever unit is on top becomes the next unit on the bottom. We're converting moles of K2CO3 into trying to figure out the theoretical mass of KCl. So our mole ratio here is 2 KCl to every 1 potassium carbonate. And lastly, to get the mass of potassium chloride, we need to now multiply by the molar mass of potassium chloride. .55 grams. All right, so let's go ahead and do the math. 45.8 divided by 138.21, excuse me, since it's on the bottom, times 2 times 74.55. The most amount of potassium chloride we could have produced from this amount of potassium carbonate is 49.4. But we actually only produced 43.3. So now we have the two numbers that we need to do the percent yield. So the amount of potassium chloride that we actually get in the lab divided by the amount of potassium chloride that we theoretically could have gotten at perfect completion times 100 will convert this into a percentage. .7% yield. So we almost got 90% yield, which would be a very large number in typical lab settings. So that's a pretty good percent yield in order to form products. Okay? So that's how you do a percent yield problem. We got to figure out the theoretical mass from the values given, just like we've done before, but now we're going to be given an actual laboratory mass, and now we simply divide those two to figure out what percent of the absolute max did we actually get to. Okay? So your homework now is to do the 4 problems on the very last page of the packet, page 17. In some of these, like we just saw, you were given 1 mass of 1 reactant, so immediately that is your limiting reactant, and you're given a mass of product, which is your actual yield. But in some of the other problems down here, you're given amounts of both of the reactants and given an actual yield of the product. So here, this ends up being a limiting reactant problem like we did in the previous lecture, where we have to figure out the amount of ammonia that could be produced from each of the reactants individually to see which of the 2 reactants is the limiting reactant. Okay? And from that value, that will be the theoretical yield. It's going to be the smaller of the 2, and then you can do the percent yield. So go ahead and do these problems that you find here in this packet. The answer keys are online in Canvas. And once you're done with this, next week, or if you're doing this Monday, which would be now the, let's see here, would be the 19th, there will be a quiz and then a review, and then that'll lead us into the test. So next week we'll have a quiz off of limiting reactants and percent yield, and then we'll have a practice test, a review test to get prepared for, and then the actual test itself that you will give coming up here in a couple weeks. Okay, and that'll be the conclusion of the unit of stoichiometry.